Hi, my name is John.
My name's Davis.
My name is Tim, and we're Group 9 of this year's senior for senior design in college engineering, electrical engineering.
Okay, so I'm going to start off by giving you a brief overview of what our project was. Our project is an inertial navigation blimp. It uses an inertial measurement unit, which is capable of taking in acceleration and rotation data. And from these readings, the blimp can determine its current position and navigate to corresponding waypoints automatically. There is also a software program that was created for the entrance of waypoints and also to give the user capabilities like telling the blimp to hover or telling the blimp to shut off its motors. These commands are all sent over wirelessly through the use of XBee modules. And there is also an option that gives the user real-time control of the blimp's movement. So it pretty much turns itself into an RC blimp.
And next we will go over our top-level block diagram.
So how we're transmitting wireless data from our computer to our blimp is we're using the XBee Pro, which acts as a radio frequency receiver and transmitter. It broadcasts at about 2.4 gigahertz and has a range of about 100 feet. We set the baud rate on the XBees to 9600 kilobits per second because we wanted the data from our computer to the XBee to get there reliably, and we also weren't sending a large amount of data from our laptop to the blimp. To control our motors, we used an H-bridge motor driver that's in the gondola down here, and it's the model number is it's made by Texas Instruments, and it's a 754410, an H-bridge motor driver. It outputs 5 volts and 1 amp to our motors, so which is what our motors take, and it's also TTL logic compatible, so the microcontroller can directly control the motor driver, which controls the motor's logic high or logic low. And Davis will give us more input about how exactly the microcontroller, how we use the microcontroller in our design.
Okay, so we chose to implement an Atmega 48 microcontroller in our design. And we are running it off of 3.3 volts at a frequency of 8 megahertz. We utilize its USART capability to interface the XBee with the microcontroller. And this happens through 3.3 volt TTL logic. We also utilize its analog to digital converter to take in the 6 analog readings from the accelerometers and gyroscopes. These analog values are then converted to DC values through its ADC capability. The microcontroller also supplies 6 logic high or low outputs to 6 different I/O pins. And these I/O pins are connected to the DC motor drivers. So that supplies the proper logic to drive the motors. I'll talk a little bit about the balloon. Not much to say here. It has a fill volume of 24 cubic feet, and it's 7 feet in length. You look at our motors over here, and we just chose a real simple design. Tri-fan system, 3 DC brushless motors, which are capable of being powered off of our DC motor drivers. So I'll hand it off to Tim, and he'll talk about the rest of the system.
Alright, to finish off our system, we have our IMU chip, and it has 3 chips on this. We bought it off of SparkFun, and the first one is accelerometer. It measures acceleration in 3 directions. And this one, the sensitivity on this is 300 millivolts per G. And then the next 2 chips, it measures rotation in the yaw, pitch, and roll directions. And the specs on this is it has plus or minus 300 degrees per second. and the sensitivity on this is 3.3 millivolts per degree per second. And all three of these run off of 3.3 volts, which leads to our power supply, which we have down here at the bottom. And the battery that we're using is a basic RC motor, basic RC battery. It's a nickel metal hydride, and it's capable of pushing 1100 milliamps per an hour. And the spec on that is it has 7.2 volts. And we're regulating that 7.2 volts down to 3.3, and another regulator regulates it down to 5 volts. And these regulators we bought off of Dimension Engineering. One of them, like I said, is a 3.3, and that one's capable of pushing out 1 amp. And that one's to run our IMU and our microcontroller. And the next one is adjustable regulator, and that one is we regulate it down to 5 volts, and that one's running our 3 motors, and it's capable of pushing out 3 amps max, 1 amp for each motor. And these 2 regulators are a switching regulator to get the most out of our system. And this concludes our whole system right here.
I want to talk about a special design consideration that we made. It pertains to the placement of the IMU, which is at the top of our blimp balloon. It's isolated from the rest of our circuitry. Initially we had it down here by the gondola, but what we figured out was that the motors were creating a lot of vibrations, and those vibrations were being picked up by the IMU. Thus we were getting very faulty data, and the navigation was getting thrown completely off. So by moving it up there, we reduce the amount of vibrations that got up to it. Also, this ribbon cable used to not be wrapped up, but because it created this hole right here, we wrapped it up. Ribbon cable was so sharp that it cut through the balloon. So I believe those are 2 very special features to our design.
Since we didn't get our navigation code working, we're going to show you guys a quick demo of our real-time remote control. So we're going to send the first waypoint to make it go up, and then after that we'll override it with the remote control. So it's going up, and now Davis is going to override it. And now Davis is in control of our blimp. Go forward. See if you can land this, Dave. Go back. Go back. Backwards.
Up, up, up. How much longer? Are we concluding?
Alright, bring it to me, Dave. Since you couldn't park it. Go. Alright, so that pretty much concludes our demo for you. And as you can see, Davis is controlling it with those buttons up here at the corner, which is up, down, left, and right. So that concludes.
Tips for next year's seniors is make sure you order your parts early, and also when you're ordering your parts, watch the package types, because some of the package types you won't be able to solder them onto your design. And we wish you guys the best of luck.